Hi, this is Ari Everett for class CSC 120. This is my conversation piece number 2 for the combinational circuit module. I'll do a quick review and recap of the project and then get into working through this practical workthrough of it. We were to create a combinational circuit based off our learnings in the module and expand upon that. So I started with brainstorming on my iPad here, just a general high-level concept of elements that I want to include, a typical high-level abstract process of it, of input, processing, and then output. 3 things I wanted to focus on were switching, multiplying, and large input devices. I have not created anything larger than a 4 input or 4-bit device, so I wanted to try my hand at that and expand on my knowledge. So here first, I started with creating a few different devices. It was a bit of trial and error because it proved more difficult than just watching the video lessons or remembering from the labs that we had completed, because not only was I creating those circuits from scratch, but I also wanted to expand on them by either adding 1 to 4 more bits or combining them in ways we haven't before. So I created this inequality. I wanted to be able to spit out something that was after a comparator, but I couldn't get that to work with 8 bits, which would have been a very large design. I have a multiplier here, and I was successful with that. So I created a 4-bit multiplier with the AND gates. In the video lessons, they mentioned the mux. I tried that here in this design, and I was unsuccessful. So if I had more time or in my next iteration, I would definitely look to make a more efficient and faster, lower propagation delay design with my multiplier. Here's my mux 8-bit 2 to 1 that I created from scratch. This was successful. 4-bit, I had a bit of trouble here coming from the 2-bit and using that as a subcircuit. So I built this one from scratch. And then I did my 8-bit adder. I did a 4-bit adder and this full adder as a subcircuit, but I wanted to go beyond that and try something that adds 2 larger numbers. And this is what I came up with. So this is my final design. It adds 2 4-bit binary numbers and outputs an 8-bit binary number. So this is essentially a data routing of arithmetic operations with a selection tool. So there are 2 different routes it can go. It can go, the 4-bit A and B numbers can be processed through this upper route, which is add the 2 numbers together separately, multiply them together separately, and then add the sum of those and then output them here. Or with this mux and the selection bit on, we can just multiply them together, and you can see the branching here goes to the mux. The selector will switch to that and just output the multiplication. So let's do some examples here. Let's do something really simple like 1 and 1. So with the selection at 0, you can see it's just multiply. So it routes through the multiplier here, branches off and goes away from the adder and into the mux here, which lets it know that it wants to let through only the multiplier side, and it outputs 1 because 1 multiplied by itself 1 is 1. Now I'll turn this on to route it the other way. It will add them together separately, which is 1 and 1, so that's 2 deci, and then multiply them. 1 times 1 is 1, and then add that together. So 2 plus 1 is 3. And so we should have binary 1, 1, which is deci 2, 2, which we do have here. We can do more examples. Let's do something like 3, and this is 4, 2, 6, 1, 7. 7 and 3, so we can do that math in our head here without writing through just to double check ourselves. 3 times 7 is 21, so let's turn this off. 21, so this is 16 plus 4 plus 1 is 21. And then let's flip this back on, and this will multiply it separately, which we figure out is 21, adding them, which is 10, 7 and 3 is 10, and then adding those together is 31. So let's see there, 16 plus 8 is 24, plus 4 is 28, plus 2 is 30, and plus 1 is 31. And that's it. I think this has some basic practical applications where if you have a strict and static arithmetic operation you need to send data through, this is what can be used. Let's say it's something that needs to be done over and over again. Either it goes one route, it does the multiplication, or based off of some condition, it goes another route. Thank you.